Hi, thanks for coming. Thanks for inviting us to Crikeycon. We're really glad to be here. We came all the way from Perth, and that's a long trip. So,
Yeah.
first Crikeycon for all of us, so that's good. So, today we're presenting our talk, which is Let's Play AI Super Metroid.
Sweet. So we're going to start out. We'll talk a little bit about who we are, a little bit about what a Super Nintendo is. Some of you may have heard of it. We will be talking about, like I said, machine learning and AI. It's like the new coolness. You can't do security without it. So that's what we're doing. And a bit about our project then.
Yep.
Cool.
So, just brief introductions. My name is Clinton. My handle is Swally. This is Peter, Chronic D, and this is Omnifocal, or Jack. And between the two of us, we work at Asterisk as penetration testers, and Peter is an academic who works at ECU.
Yeah.
Cool. So you probably noticed that, like, in the right-hand corner of the screen, there are videos playing. So that video will hopefully go the entire length of the presentation, and it demonstrates our artificial intelligence that we trained playing the game Super Metroid, which is pretty cool. Just want to make mention quickly that, like, although Scott's introduction was really cool, we are not experts in machine learning. We can't actually even read, so, like,
It's very hard.
Please don't take too much from this.
It's been really rough doing this without reading, I got to be honest.
So let's get started. So first off, we'll introduce a bit about console emulation and the Super Nintendo.
All right, so this is the Super Nintendo. It is a very, very good console that was released in 1990. Apparently there are 49 million of these things sold. I bought one.
Wikipedia, like, I bought one too.
Yeah, so that's two.
We recycled at least two back into the pool.
We sold ours at Cashies. It's really sad. It was a
allowed to
bad
buy one?
decision.
Yeah. Sorry, you.
Man,
My Super Nintendo and its box at home looks nothing like that.
that's weird.
You got the
You probably
wrong
got a
one,
knockoff.
Man. Yeah. There was a lot of imitations floating around
Yeah.
too.
I
think you got ripped off,
real
man.
problem. Yeah. I'd trade it in at Cashies, see if you can get your money back. So they used cartridge-based games. It was a top-loading console. They had a couple of different variants depending on whether you're in the PAL region or the NTSC region or in Japan. And it was a 16-bit system. It was pretty cool. We really enjoyed it.
Yeah.
Best console ever.
Okay, so Super Nintendo emulation, or really any cartridge emulation of a cartridge-based console, it is achieved through a couple of processes. So first of all, obtaining a dump of the data from the cartridge, which used to be really hard. It involved soldering irons and parallel ports and all sorts of stuff. And now it's like a USB dongle you get on AliExpress for like $8, and you just plug it in and it's done. All of these emulators support things like save states, reloads. The better ones will support like real-time rewinding. So when you lose, you just like hold down a button and then you can lose again. It really does help when you're bad at video games, like me.
Yep.
There's all sorts of different emulators out there. We used more correctly, a simulator called BSNES. So ZSNES and SNES 9X are emulators, as in they translate instructions from one CPU architecture to another, where BSNES is a simulator and it simulates all of the circuit paths within the Super Nintendo. So you get perfect execution of the code. And this is really important if you're playing Jungle Strike on the Super Nintendo, because without...
You want that audio, right?
No, the helicopter doesn't have a shadow.
Oh, yeah.
Because they achieve the shadow through abusing a flaw in one of the chips.
Literally unplayable without that.
Yeah, can't do it. All right. Cool.
So the actual emulator sort of suite we used was a system called BizHawk, which is a Windows-based application, and it loads different emulator cores such as BSNES, ZSNES, or SNES 9X at the user's leisure. The good thing about BizHawk is that it supports Lua bindings, which is why it's mainly used by the tool-assisted speedrun community. They like to be able to script things and playback and etc. And also, sorry, you'll notice that the boss that Metroid is currently fighting is called the Worm, and he's pretty good at it. So just keep an eye on that. So again, we're not experts in machine learning, and we don't really want to bore you with machine learning. So we'll just give you the basic rundown. With machine learning, basically, a computer gets input, and the computer then does some sort of crazy math and guesses some form of output. The guessing process is usually achieved through some machine learning algorithm, of which there are many. They have different objectives, different goals, and different operations, etc. And you can break them down into typically supervised, unsupervised, or reinforced learning. The problem domains that machine learning tries to solve are, again, supervised, which is basically saying that you provide some form of training data to your machine learning algorithm. So the input data is known to be good, that's trained, and then you can kind of assess how the machine learning algorithm assesses non or unknown data based on the training set.
Yeah, essentially like think about a folder filled with pictures of cats and a folder filled with pictures of not cats. And you're like, hey, these are cats, these are not. Can you tell me about these other photos? Are they cats?
And then you go, hey, here's a hot dog, and it goes, not hot dog.
Yeah, it's supervised, right?
Yep. And then there's unsupervised learning, which is basically there's no training data provided. You don't know what sort of classification the input data has. So you're just saying like, hey, here's a bunch of information, make something of it. And the thing goes, oh, okay, this looks like it might be related or whatever. Also there's reinforcement learning, which is used for robots. So, neural networks. Neural networks you've probably heard of before. It's basically a synonym for machine learning these days. People use it as a buzzword. They're like, oh, these terms are interchangeable. They're not. It's very commonly used. It's, Google machine learning, you'll get the first result will probably be an artificial neural network.
But based on, what some vendors are calling neural networks, if statements apparently qualify.
Very long switch case statements.
Yeah, long switch cases, really complicated conditionals. Machine learning.
Yep.
So basically the idea is you simulate the human brain by having pathways between input nodes and output nodes connected through some hidden layer, which is just black magic. And typically they're used for pattern recognition tasks. Lol, silence. Okay, evolutionary algorithms. So our our AI system uses evolutionary algorithms as well. These include things like genetic algorithms and genetic programming, etc. And the goal with evolutionary algorithms is to kind of simulate the organic biological process of, human evolution, organism evolution. And this is performed by taking a, genome and then, checking its traits and then breeding it based on whether or not it's the fittest thing in that particular population, and so on and so forth. Eventually, you'll get a kind of family tree of really weird pathways between different genomes and populations that kind of is disturbing, but it's cool.
There might be some legal issues with some of those.
Yeah, in many states. And typically these genetic programming or evolutionary algorithms are used for search optimization problems, so trying to find the best parameters, say, for a particular function or something of that effect.
All right, so really the most important thing if you're doing evolutionary A&N stuff or really any evolutionary programming is we need a good way to determine how good or bad a particular thing is, a particular network. Now, essentially we need to decide what is good and what is bad, and that turns out to be really, really hard. So if we look at Mario as an example, we could say if Mario beats the level, that was good. If Mario completes the level faster, that was better. And if Mario dies, that's really bad. Okay? And we'll talk about the fitness functions we use for Metroid later on, but it's easy to get it wrong. Thinking about it as a human it does not lead to good results.
Yeah.
So the ultimate purpose of the fitness function in terms of evolutionary programming is, of course, to decide what species are allowed to continue on to the next generation in order to perform that process of natural selection.
It's eugenics.
Okay, so the project that this kind of was all based upon was a project called Mario, and it was by a guy called Seth Bling, who is a computer scientist over in the US. And incidentally, he currently holds a number of world records for Super Mario World speedruns. The guy is really good at Mario. He loves it. One particular speedrun he holds a world record for at the moment is one called the any percent no level exit speedrun, which is basically he performed a memory corruption bug in-game in a particular level by grabbing a shell and jumping on Yoshi and then jumping off Yoshi and stuff and building up the stack. and then eventually calling the end credits function, like within the level. He can do it within 45 seconds.
He
Look it
does
up.
the
It's
memory
fantastic.
injection on a SNES controller by hand.
He's kind of doing like
it's
by
actually
hand rock
really
chains
cool.
in memory. Yeah, it's
He's
crazy.
doing like ROP chains in memory on a SNES using
Yeah.
a controller.
It's crazy. You should watch, like, Google up Seth Bling's YouTube videos and watch that. It's
insane.
yeah.
So his system, Mario, used a genetic neural network, which basically combines the evolutionary algorithm, genetic algorithm, and also an artificial neural network. And basically, the genetic algorithm trains the neural network, which is the actual thing that's playing the particular game at the time, and then determines how well that A and N played the game, breeds the ones that did well, and bins the rest, so on and so forth, until Mario eventually beats the level, which he was actually pretty good at. Like, Mario got pretty good at the basic levels.
Absolutely.
He got very overfit very quickly, but those first few levels he was very good at.
Oh,
Yes. Yeah.
One.
So we had a lot of discussions, and we said, well, Mario is pretty easy, like, in terms of objectives, but, Mario sucks. Like, we don't like Mario. Who likes Mario, right? We like Metroid. Metroid's way better.
It's objectively the best game.
Exactly. Best game ever made. So we had a look at it and we said, well, can we get this thing to play Super Metroid? First thing we looked at was the objectives. Now, Super Metroid has vastly different objectives to Super Mario World. You can't just say, like, okay, Metroid is able to run to the end of the level and therefore he wins the game, because Metroid doesn't need to run to the end of the level to win the game. Metroid has a lot of different pathways, and there's backtracking and different objectives at different times. There's item pickups, enemies to kill, etc. So yeah, it's
tough. It's rough.
It's pretty tough.
Yeah, it's
It
hard to
essentially,
automate, so we didn't.
It leads to a massive blowout in training time because you need
Yeah.
a large number of iterations and species on all of those different objectives to train the ANN up to a state where it's usable.
Yeah, and coming up with generic fitness for that is...
It's almost impossible.
It's doable, but not in a way that would work.
So what we did is we had a look at the the game Metroid, and we sort of disseminated what the components were. So if you have a look at the screen there, if you guys haven't played Metroid before, so I've just like kind of annotated a sort of normal screen. You've got your kind of head-up display, which contains things like ammo and energy, etc. You've got enemies. One is frozen, so there's different states for different beam weapons that Metroid accrues over his time. There's a beam shot being fired, so Metroid can shoot different beams. There's special weapons. There's normal weapons. There's charge. There's all these different kind of variables in play, and then you've got the character there, Metroid himself. What?
Metroid's a robot.
Yeah, Metroid's a cyborg robot.
Yeah. All right. So we fixed Metroid. Essentially, the goal of this was we didn't want to have to play video games anymore, so we decided to automate it. Now, just imagine a world where you're free, like all the time that would free up if you just didn't have to anymore.
The games have to be played
Because
regardless.
it wasn't going to play itself.
Yeah, exactly.
But now it does, so good. All right, so essentially we create the species in genomes and we run the ANNs. We'll look at that on the next slide and talk a bit about them more. And we cull the worst ones. We say, these were the worst of this particular generation when it comes to meeting those fitness scores, so we kill them. And then we breed the fittest of the generation to create the next generation and apply some random mutations. Now, we then rinse and repeat that until the memory leaks are too extreme and the performance drops to the floor.
There's a lot of memory leaks.
It's really rough, and
really
oddly
bad.
enough, it's not in our code. It's who would have thought that like it wasn't a considered use case for these emulators to be run for weeks on end?
So for every frame that Metroid's playing the game, we take the inputs, which are at this point basically all that is on screen, so all the tiles, all the sprites, etc. We also have a few additional things that we look at, which we'll get to in a second.
Yeah, I just want to talk about the building of the inputs. Traditionally, when you're using ANNs, you're not supposed to perform feature extraction. You're just supposed to give the ANN the entire set of data. And traditionally, with video games, this would be done by just giving it access to the console's RAM and allowing it to decide what to use and what not to use.
That was impractical.
It was
Like, we couldn't do
impractical due to technical issues with the emulator and how it was implemented. So we essentially had to reduce the size of those inputs. And we did that by pulling apart the console's memory and trying to map out basically, like in that upper left there, what was important to understand what was going on in the game, which isn't ideal, like I said, but it makes it fast. So you can see that in the map.
Not to mention that giving access to the ANN to the entire memory space of the console would have caused an even bigger slowdown than what we
It would have been terribly slow.
Much more memory leaks.
Okay, so you see on the left the inputs, on the right our outputs. So the Metroid AI has access to outputs, inputs. Can you show it on the other side? Yeah. Okay, so we gave it access to all the buttons on the controller, except for start, because we didn't want it to pause the game. Okay?
Which it would do.
Which it would.
Constantly.
Yeah, it was terrible.
Yeah.
Okay, so we removed its ability to press the start button and gave it everything else. And you can see in the middle there those lines that are connecting the two sides. These are essentially the ANN's mapping to say if these inputs are active or these combinations of inputs, we will press these buttons, these outputs. And it evaluates this every frame to decide what to do.
I just want to pause and say this, this particular enemy that Metroid's fighting right now, he's pretty good at.
That's true.
Okay, so we'd just like to acknowledge Jack at this point. Jack made a number of contributions to our code base. One of the contributions he made, the most notable one, kind of leads into the discussion about trying to give Metroid a bit of a heads up. And
Feature extraction.
Exactly, feature extraction. So he generated our has missiles function, which determines whether or not Metroid has missiles in his inventory.
So there's what's his name? Hold on. Okay, so Kevin Swanson is known for having produced the most in-depth reverse engineering effort for the Super Metroid title. So he's got these wonderful sets of documentation with annotated disassemblies of the entire game, some mostly accurate and complete memory maps with some things missing and some things wrong. Anyway, after a lot of frustration, I thought, I'll find a way to email this guy, and eventually did find an email address. It's not on his website. Maybe it is now, hopefully. Anyway, emailed the guy and was like, hey, so I notice, this isn't there. These things still show up as being active when they're not actually on the screen. What's going on? And some other questions. You can read it if you want, but it doesn't really matter. Also, what things are and how to tell. And I actually got a reply. Wow.
Within a day or two.
Yeah, it was absolutely amazing and extremely useful information. So I'm not going to talk too much about the memory addresses and everything else, but what was really useful about the reply is that it provided information on certain types of data structures that are used within the memory of Super Metroid. And essentially with this, we were able to look at the way objects were manipulated throughout the entire game. Essentially, this was the missing piece for us, which could allow us to perform meaningful extraction of information from the system's memory. And it led to this.
So the first thing we needed to do was figure out where, again, as Peter said, where things were stored in memory and what kind of things we were interested in making sure Metroid was aware of, because obviously we didn't want to give them too much information. We didn't want to overfit or overtrain the thing. We wanted to give it a fighting chance, though, and at least with the game, there's a lot of, things being thrown around, a lot of projectiles being thrown around. And we needed to know if they were positive projectiles, like pickups, things that, would increase your health or ammunition, or perhaps negative projectiles, things that would damage. So we coded based on a bunch of existing sort of tool-assisted speedrun hitbox layouts, that sort of stuff. We took some of those scripts and we reversed them and made them applied to
our situation.
Our situation, yep. And we added things like, these are good projectiles, these are bad. So as you can see in this picture, it's pretty cool. We've got the Space Pirate, and he has 20 hit points, and his projectile, which is a laser beam, is bad. Like, that causes damage to Metroid, and he doesn't like it. So
it's worth noting, we don't tell the ANN what is good and bad, we simply tell what is there and what is not.
Yeah, exactly. But we needed to know ourselves.
we needed to know, yeah.
And this particular screenshot marks a significant milestone in this development
process. This was after
process.
weeks of effort.
He called me, he's like, dude, I've got it.
I was very happy.
Yeah. Similar sort of thing.
All right, so talking about our fitness function. So we had to figure out how to measure what ANNs were good and what were bad at this stuff. So we decided, okay, Metroid should be rewarded for killing or damaging an enemy, for collecting a pickup, so getting ammo, getting health, or for being alive, for living longer. But we also needed a way to punish Metroid for standing still for too long, just doing nothing, or for taking damage, running out of health, or dying. Okay, so this worked pretty well. So essentially we said, okay, Metroid's health minus enemy's health minus some stuff if Metroid's dead, and I think maybe like 1 fitness point for every couple of seconds it's alive. Now, there was also some time down. We'll talk about that later. All right, so this worked really well for boss scenarios, kinda. But other scenarios that weren't so straightforward just didn't work. So things like jumping across platforms or climbing up a room, things like that, it just didn't do. Like, we set it up with the fitness goal of jumping up a bunch of platforms to reach a top platform. Ran that for 2 weeks, and it jumped up like 2 of the 40 platforms. So it's
did not get
yeah, certain things we are bad at.
We gave up.
Yeah, perfecting the fitness function was probably one of the most difficult parts of the whole endeavour.
Yeah, and it's not perfect.
I mean, we had the idea that staying alive for longer is better, and that just led to Metroid learning to dodge projectiles, not damage the enemy, and not die, which is not helpful.
We had a number of runs.
That's not good.
We had a number of runs where Metroid would just roll around in a ball along the ground, like dodging projectiles for like hours, and it was doing really well by its own measurement, but like
it was funny to watch.
Beating the game.
Yeah.
It got very good at
And this is
surviving
it,
for
like-
a very long time and not doing anything else.
It's a very human thing to say living longer is better.
Yeah, it was like malicious
no.
compliance. Like
Yeah.
he learned very quickly that he just
Yeah.
needed to beat the game, and yeah.
It was almost a bit philosophical, really, because he was living forever but not doing anything with his life. Like, he would just not die.
It's almost
Yeah,
a metaphor
that's
for ours. Okay, so let's get into the bestiary. So, as you can probably see in the top right-hand corner, we've got a few enemies that we pitted our ANN against, some of which Metroid was really good at fighting. Like, Metroid managed to beat, which is amazing, and we were pretty stoked, to be honest. The first boss, Charizard, which is also known as the robot.
Also known as Chorizo.
Yeah, also known as Chorizo. Metroid was pretty good at beating and could consistently beat after about, 3 or 4 days of training time.
With the later versions, like a day.
Yeah.
Yeah.
And yeah, so this particular boss has a vulnerable midsection that's vulnerable throughout the entire fight. It's fairly weak, so it only takes a few shots, and I guess the ANN managed to pick up on that fairly quickly. The next boss that Metroid was really good at was the worm, right? And the worm is a different boss as well because it has a different attack pattern. It's a fast-moving sort of boss, so if you're not well prepared, you can succumb to it fairly easily. But it also goes off-screen, so it goes through those holes, as you can see, sort of there. There's a few holes on the image. So it'll kind of traverse through that and enter the background, at which point it can't be hit. It's invulnerable. Metroid doesn't seem to care about that, though, does he?
No,
No.
not at all. Just does incredibly well. It's strange.
Turns out the background state doesn't actually affect the ANN's ability to see where he is, so he can kind of predict where he's going to come out,
Yeah.
which was
Oh, well.
interesting. Okay.
Feature extraction doesn't always work.
Yeah. So there was a few enemies that our ANN made significant progress against, but could not ultimately beat, which is a problem. But I guess given a bit more training time, we reckon we could probably get him. Actually, the one on screen at the moment, the golden Charizard, he does pretty well against. So.
Yeah, we have Ripley, the robot bird. This boss is actually pretty interesting, and I think the AI will eventually beat it with a couple of months more training, maybe. So this character uses advanced strategy, basically flies around, has different attack patterns, is extremely strong, and its tail dishes out a lot of damage, but is invulnerable. There's also lava at the bottom of this stage, and it took a while for Metroid to learn that being in the lava was bad.
Yeah. He loves going in the lava.
Yeah, it really did. It would jump straight in there.
Yeah. But it might be up next, I believe. But yeah, anyway, when you see it, he does pretty well against him these days.
Oh, yeah.
Yeah. So this is Golden Charizard, which is actually on screen at the moment. Now, basically, this is similar to the previous Charizard monster, except it's a lot stronger, and if you use super missiles against it, it gets really, really pissy. Like
Picks them up and throws them at you.
Yeah, like throws them at you, which isn't a problem. So the process that Metroid's going through, where he charges a shot and then releases it, and you can see the damage pattern going on there. That's actually that's probably the best way to beat him. Like he's getting the strategy that most speedrunners would use, except
it's actually really, really interesting what's happening here. So the network's evaluated every frame and has no knowledge of the previous frames or time passing or anything like that. It's essentially brought into existence and evaluated in every single frame. So the fact that it somehow developed the capability to charge the charge beam for a certain number of seconds and then release it is like a really interesting side effect of how the network works. Essentially, it's based on the movement of the boss and jumping. So essentially, it's learned to fire when the boss is in a certain position and the floor is in a certain position. So it jumps constantly and sees that the boss has moved to a certain place. So it starts charging when the boss is in a certain place and the floor is in a certain place, and then releases its weapon again. So it's essentially developed the ability to time shots without any idea of time or persistence of state from one frame to the next,
and if you
which is really cool.
If you look at the color of the boss currently, you can see that he's changed a lot from the original color, which is featured on the left, which kind of indicates how much HP he has left. So his colors are gradient depending on how much health he has. So yeah, he's not far away from actually beating him.
One of the most interesting aspects of this project for me was seeing the AI discover those speedrunning strategies that independently, all on its own, like the X-Ways beam against the worm boss. Very interesting.
Yeah, so he performs a relatively unknown attack against the worm boss, which we talked about before. But yeah, he managed to discover that if you hold a charge beam whilst having a power bomb selected, you could perform an additional attack, which would do more damage.
Yeah, it's an interesting sequence of things. It's like charge the beam, have the power bomb selected, and then morph into a ball, right?
Yeah. No, it's just be straight up.
Oh, right, sure.
It seems to me that there's not much going on in terms of avoiding bad projectiles.
Yeah. Absolutely. So that's all down to the fitness function, right? So how much he gets penalized for getting hurt, and in this case, he's probably not being punished enough, but he probably has enough HP that it's not concerning to him, if you get what I mean. At this point in the game, he has, probably about 1,200 energy. So to start with, so getting hurt by like 30 or 40 is probably seen as a minor concession.
Sorry, is that to say that this scenario of just fighting a boss is isolated? You're not taking into account like starting from level 1 and...
No, we're just looking at boss fights.
Yeah.
The other stuff didn't really work.
Not at all.
Oh yeah, this boss does very well against...
you'll see him exhibiting some good strategies against this guy, nailing some hits. And then finally we have enemies that Metroid didn't actually fight very well or could not complete at all, or just plain stood there. You probably saw that before, but against these enemies, he just stood there and didn't really do anything, and we don't know why.
Essentially the way it was mutating and everything, it just never did anything, so it never had a fitness reward, so it just kept breeding new generations that stood there until they died. It was weird.
So, this brings us into some of the challenges we faced during this project.
Lua is bad. It's a bad language, and if you like Lua, you're a bad person.
Yeah,
no,
agreed.
One-index languages don't make sense. We had never programmed Lua before, any of us, so we learnt Lua looking at the previous sample ANN code from Seth. And we saw all these one-indexed arrays, and we're like, well, that's weird. Why are they one-indexed? So we fixed them. And then we had to fix all the off-by-ones, and then we found out Lua was supposed to be one-indexed, and did that and left a bunch of the off-by-ones in. We can't find them all.
Yeah, we thought it was just something that Seth was doing in his code, but it apparently is the language itself.
Whoops.
Oh, God.
The code for Mario was pretty bad. There were a lot of really deep nested loops, which were being evaluated like several thousand times per frame. which weren't needed. So we managed to do a lot of performance improvements by removing those and fixing things up. You can see some things here. There's some code on the screen. That's good. Yep.
So these are some example code snippets from our particular ANN code that was based on Mar.io. One of the most funny things was that the original Mar.io code implemented its own serialization and deserialization routines, which
that didn't work.
Just didn't work at all.
Which you can see commented out right here, where he basically new line separated like the entire state of the application.
It seemed like
didn't
I
reload.
wanted to really reinvent the wheel, so we just imported a library and did the whole thing in 3 lines.
Yeah.
It was a lot better.
All right.
Zoom out.
There we go.
Cool. You want to talk about Git?
Yep.
Okay, so we began the project using a Git repository. We wanted to keep things simple with a single branch, and
Version control is good,
Version
right?
control is very important.
It saved us a lot.
Once we got to 3 people working on the same project, we tried to do things somewhat properly, and they kind of broke down. There's certain practices that I think we didn't really develop. We were essentially just committing our code without communicating or thinking about it at all. And
Pull requests were not a thing we did.
No. So it got a little bit messy.
We came up with a sweet method for resolving conflicts, though, which we call the above-below method, which just entails or involves someone pasting a screenshot of a diff, and we go top one or bottom one. That's the one that needs to be resolved.
Look, it worked out pretty well.
So we would intentionally break our version control and then make Jack fix it. We did that, I wouldn't say hundreds of times, but easily 50
We did
plus.
it once badly.
Well, you'll see how many times we did it.
Look, I did it once and then I just didn't do it again after that.
Yeah. So you can see here our wonderful Git graphs. They're good. They should not look like that.
And there's a sweet picture of Peter's desktop at work, which is running all this.
Sure is. You can't actually disable the sound in BeastNess. Yeah.
It was really
So
pretty noisy.
when I did need something that used sound on my work computer, it would make this just terrible noise of all these things playing at like 8 frames a second at once. It was just this. I'm happy that's gone.
Your office got pretty warm too.
Oh yeah.
Yeah.
Yeah, not sure why. So the last thing that really sucked was BizHawk. Now, there's definitely a market for a better emulator than BizHawk. Memory leaks so bad. It's really, really terrible. Also, it only runs on Windows, so...
Yeah, to give you an idea, we'd run it overnight. It would start out using 300-400 megs of RAM, and it would be consuming all of the 16 gigs in that box by morning. It's rough. I originally thought it was our script that was leaking memory really bad, so I turned it off and just ran BizHawk, and no, it's really bad. I don't know. So this is what my desktop looked like for a while. I just used my laptop. It was fine.
All right, so we'll kind of end this on some future suggestions, some things that we think that would help this sort of research in future. First off, now this sort of exists in some form, but like a completely headless emulator, which would resolve some of the CPU GPU issues we'd face by having to have the graphics displaying all the time when we didn't really care about it at all. With some bindings that support a sane language.
Please don't make us use Lua again. Yeah.
I never want to see that crap ever again. Better coders, which we're not.
Oh, look, we are not professional programmers. We break things and write words. That's what we do. And
probably to try something different in terms of machine learning, like different algorithms, different training data, etc. GNN, the system we built is basically probably equivalent to brute force. I don't know if it's better or worse. I can't tell.
There was another project where they did the brute force method, and it was a lot worse. So ours runs at about 1/8 real time. So the video's sped up a whole bunch.
Oh, yeah.
But the brute force methods that try and accomplish the same thing through looking through every possible input per frame and then evaluating fitness based on that, they tend to operate days per second of game time. So brute force is probably as effective or more effective than our stuff, but it's slower.
All right, does anyone have any questions?
There were weights, yeah. So there's, weights, nodes, all sorts of stuff, yeah.
Sorry, the question was what was in the genome? Were there weights or was it just...
Oh, you answered this time. You read more of that code than I did.
Sorry, what?
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 You answered it.
What?
Yeah, cool. All right.
Good. Yeah.
I thought we were repeating the question. We answered it again. I don't know.
The question was, were we crossbreeding them with weights? Yes, we were. Yep.
Yep.
Question? Sorry, the question was the context one single frame? Yes.
Yeah, we've looked into, in future, implementing RNNs so that it can have context between frames, but we've not done that yet. I actually think that would improve performance quite a bit. Well, yeah.
The only context we stored between frames was the previous fitness result of the previous frame, so that it had something to compare against to determine whether it's improving or not improving.
Yeah, but that information wasn't available to the ANN itself.
Yep.
Absolutely.
Yeah.
Yeah.
So consider the lifetime of the neural network from start to finish of that particular playthrough, and that's where the genetic algorithm comes in.
Yeah, so essentially it's just, it has no memory of what's happened.
Yeah, it's
just
not reincarnated.
Every frame it's going to go, what up? Yeah.
Potentially re-implementing the project as a recumbent neural network would be a next step.
Yeah.
Yeah.
To get that through different levels of, say, let's say heritage, I guess, but you've also introduced mutations. How
Yep.
do you do that?
Okay, so the question was about how mutations were introduced through different levels of heritage or different populations. Generation, sorry. Basically, it's random chance. So you apply a random mutation on particular traits, which is eventually becomes binary, right? You're just like, hey, here's a species. I'll flip a bit here and there randomly, depending on whether or not it hits a randomization.
Yeah, so essentially there's just a probability
So like the
whether something will make it through or not, or it'll change.
Yeah, so the crossover function takes the two parents, combines them, or takes half the genes from one, half the genes from the other, and then a random mutation is applied to that entire gene string. And says like, if it's hits 1% or whatever, mutate 1% of the genes.
Yep.
Looks like you had good, bad, enemy level, and self classes of sprites identified. Did you look at doing any more specialisation in detecting the different sprites?
No. So,
The question was to do with whether or not we actually looked at determining what other types of sprites existed so that the ANN would have more knowledge.
yeah, so in early versions of it, we didn't distinguish between walls, enemies, power-ups, or anything at all. It just saw that there was something on a place in the screen or there was not something there. Eventually, we thought, well, it would obviously do better if there was some sort of distinction between good things, bad things, walls, and stuff like that. So we broke it into this is an enemy, this is a power-up, this is a projectile, all that sort of stuff. Not saying what it is, just saying they're different, right? It did worse as a result. That was a very strange outcome. However, yeah, we've not looked at the idea of distinguishing further than that. It would increase the input space and damage performance. So we're trying to keep it practical.
Performance is already impractical, but
It's
something we gave up for performance reasons.
It's potentially possible that the result ultimately would have been better, but it would have required a lot more training time.
Absolutely.
And it's plausible you need a deeper network to take advantage of that also.
Yes, it is plausible we would need a deeper network to take advantage of the higher input space.
Yep.
Everyone give it up for these guys.